Okay, so we all want our software to be solid, right? Reliable. But how do we really know if our testing has been thorough enough? It's a huge question, one that definitely keeps developers up at night. Today, we're going to go inside the box and explore a super powerful set of techniques designed to find that answer. I mean, think about it. You run your test suite, and everything comes back green. Pass, pass, pass. And man, that's a great feeling, right? Such a relief. But that simple pass signal, it doesn't tell the whole story. It doesn't tell you what parts of your code were actually run, and maybe more importantly, which parts were missed entirely, leaving bugs hiding in the shadows. All right, so here's the plan for today. We're going to start by flipping our perspective from the outside in to the inside out. Then we'll introduce what I call the coverage yardstick. It's the tool we use to measure how thorough we're being. We'll dive into two specific levels, statement and decision coverage. And finally, we'll tackle a really critical question. Is getting to 100% the end of the story? Let's get into it.
So, to really get what we're doing, we first have to talk about what we're not doing. See, most testing looks at an app from the outside, just like a user would. That's called black box testing. But today, we are popping the hood and looking at the engine itself. And that is what we call white box or structural testing. Instead of just asking, hey, does this button work? We're looking at the code itself, the actual lines, the logic, all the different pathways to see how well our tests are actually exercising that internal structure. It's not just about what the code does, it's about how it does it.
Okay, so if we're going to be poking around inside the code, how do we even measure if we're doing a good job? We need some kind of yardstick, right? And in the world of white box testing, that yardstick is called code coverage. At its core, code coverage is just a percentage. It tells us how much of our code our tests actually ran. Think of your code as a map of a city. Coverage shows you which streets you've driven down and, crucially, which ones you haven't touched at all. It's a direct, objective way to measure just how thorough your test suite really is. And honestly, this is where things get a little scary. Studies have shown that the typical kind of informal, let's just click around testing might only execute about 30% of the code. 30. Even what we'd call really thorough black box testing often only hits around 75%. That leaves a massive chunk of your application completely untested, just sitting there, potentially hiding some nasty bugs. So how do we start to close that gap? Well, we start at level 1, the most basic level of coverage. And it's built around a really simple and intuitive question. Have we run every single line of code at least one time? This is called statement coverage, and the formula is exactly what you'd think. It's the number of lines we've run divided by the total number of lines times 100. And when we say lines, we mean the executable ones. We're not counting comments or anything like that, just the lines that actually do something. It's our starting point. All right, let's make this real. Take a look at this little piece of code. It's got a simple condition, if C is greater than 50. Now let's say we run a bunch of tests, but in every single test, the value of C happens to be 50 or less. That means the condition is always, always false. So our tests run all the other lines, but they just keep skipping right over the code that's inside that if statement. That line never gets touched. So what's the result of all that testing? A measly 83% statement coverage. Even with multiple tests, we've left a glaring hole, a blind spot, where a bug could easily be hiding. See, this is where that white box thinking is so powerful. We look directly at the code, at that if statement, and we ask a very specific question. What kind of input do we need to force the program to finally execute that missed line and get us to 100%? And the answer is pretty simple, right? We just need a test where C is bigger than 50. So for example, we could set A to 20 and B to 25. Boom, C is now 70. This single test case forces the program down that path we kept missing. And notice this, that one well-designed test was way more effective and efficient at getting coverage than our first 3 random tests combined. Okay, so hitting every single line of code, that's a fantastic start. But let's be real, code isn't just one long straight highway. It's full of forks in the road, choices, and decisions. Just because we drove past an intersection doesn't mean we explored both streets. Now, we have to test those choices. And that brings us to decision coverage. This measures whether we've tested every possible outcome of a decision point. So for a simple if statement, it means we need at least one test where the condition is true and another test where the condition is false. We have to test both forks in the road. Now, this is maybe the most important distinction to get. Decision coverage is it's stronger, it's more thorough. And think about it, if you test both the true and the false outcome of a decision, you are guaranteed to have run all the lines of code involved, right? So getting 100% decision coverage automatically gets you 100% statement coverage. But as we just saw, it doesn't work the other way around.
You know, a super helpful way to picture this is with a control flow diagram. The boxes are just lines of code, the actions. And that diamond, that's our decision point. And from there, the code can branch out into a true path or a false path. Decision coverage demands that we design tests to go down both of those paths. Okay, let's try another one. We have some code that checks if a value C is less than 0. So we run a test that makes C negative. The condition is true, and our program follows the true path. Great. But what about the other path? What happens if C is positive? Right, we completely missed the false path. It was totally untested. To fix this and get to 100% decision coverage, we need to add a second test, one where C is positive. By adding that one simple test, we now exercise the other branch. Now, and only now, can we say we've covered both outcomes and have truly tested that entire decision. Okay, so after all that, you're probably thinking, great, the goal is 100% coverage, case closed. Well, not so fast. It's an amazing target for making your testing more thorough, but it's really important to understand that even a perfect score has its limits. I really want you to remember this one thing. If you forget everything else today, 100% coverage does not mean 100% tested. Let me say that again. 100% coverage does not mean your code is 100% tested. It's a measure of how much of your existing code you've touched, but it is not a complete picture of quality. So why is that? Well, for one, coverage can only see the code you actually wrote. It has no way of telling you about a critical feature you completely forgot to build in the first place. And second, it doesn't mean your logic is actually correct. A test could run a path, get you that 100% coverage, but still not use the right kind of data to expose a bug. It's really just the tip of the iceberg of software quality. So let's wrap this up. What's the big takeaway here? White box techniques like statement and decision coverage are absolutely indispensable tools. They force you to find gaps in your testing, to be more rigorous, and that is especially crucial for really complex or safety-critical software. But they should always be used with other testing methods, never as a replacement. And I'll leave you with this final thought to chew on. Coverage gives you a brilliant, detailed map of the territory you've explored in your code. It tells you exactly what you've tested. But what it can never tell you about are the entire continents of functionality that were supposed to be on the map, but were never drawn in the first place. Thanks for tuning in.